Hey guys, welcome. Week 4, we're wrapping up the last 2 lessons of this unit, so then we'll start reviewing and go over the test here in a few days. But we're doing lesson 89 and 90. So lesson 89, we're looking at diagonals, interior angles, and exterior angles. So again, a diagonal is just going from one vertex to another, and then we have a segment. So this trapezoid or this quadrilateral will be cut in half by a diagonal, so that's what we're looking at. So depending on how many sides is going to affect how many diagonals we have. If we're looking at this hexagon, we'll do it 1, 2, 3, 4, 5, 6 sides. Trace the hexagon and illustrate how many diagonals can we have. So let's start at wherever we want. A started at A, or we can go from A to C. We can go from A to D, we can go from A to E. A to F, that's adjacent, we already have a side. A to B, same thing, that's already one of our sides. So we have 3 diagonals with the 2 sides. The interior angles right there that we make, we see that B of the hexagon is also B of the triangle ABC. Okay? C of the hexagon includes BCA, all of this. So what we can do, and why, who cares if we can count up the number of diagonals? That doesn't seem too complicated. Hopefully not. But what we can do is we can use this because we're used to working with triangles. All the angles add up to 180. A quadrilateral, oh, they add up to 360. But we don't do a lot with pentagons or hexagons or octagons or things like that. So if we said, what are the interior angles of those add up to? You go, I don't know. How do we even figure that out? This is how we can figure it out. We draw the diagonals, which form now triangles. In this case, we have 1, 2, 3, 4 triangles. Triangles, we just said, they add up to 180 degrees. So we do 4 times 180, and that gives us 720. So we know all the interior angles of this hexagon that we're looking at add up to 720. Mara inscribed a regular hexagon inside a circle. Find the measure of angles of the regular hexagon A, B, C, D, E, F. So hexagon, we just looked at that. Regular tells us that all the sides are equal. So if the sides are equal, then the corresponding angles are going to be equal. So all the angles are going to be the same, just like an equilateral triangle or square or something like that. So regular, so all these sides are the same. And so what are these angle measurements? Well, we just found using our diagonals and getting 4 triangles, 4 times 180. We know that there's 720 degrees angles in there. There's 6 angles because there's 6 sides. They're regular, so they're all going to be equal. So we do 720 divided by 6, and we get 120. They all are obtuse angles, 120, 120, 120, 120. I draw a quadrilateral on one of its diagonals. What is the sum of the measures of interior angles of a quadrilateral? Well, we know 2 triangles, 180 times 2 is 360. That's one we probably already knew without using this concept, but it's helpful to understand what's going on and where we get that. Okay, don't worry about this activity, but this, I know we will see some problems about this. So again, going around the hexagon, we turned at every corner. If we did not turn, we would continue going straight. So that forms an exterior angle. We know that this has to add up to 180 because it's a straight line, so it's got to be 180. So if all the turns are in the same direction, the sum of exterior angles of any polygon is 360. So if we know, let's take a triangle, for example, an equilateral triangle to make it even easier. All the angles are 60 degrees. So if we had, draw it. So we have an equilateral triangle. All the sides are the same. Right, well, if we continued on straight right here, this one, all these angles, equilateral, 3 equal angles, add that up to 180, we have 60. So what we're saying is this goes straight. This exterior angle has to be 120 degrees. It's got to add up to 180. Same thing down here. It's got to be 120. Same thing right here. It's got to be 120. Okay, well, the exterior angles, if we were to walk and make these turns, 120 plus 120 plus 120 is 360. So that's what this is saying. Now let's say it's a hexagon again. So each angle is 60 degrees because we know they all have to add up to 360. So we could do the thing we did, do the diagonals, the triangles, figure out what each interior angle is, or we can remember this concept that they all have to add up to, all the exterior angles have to add up to 360, and then we can do, well, there's 1, 2, 3, 4, 5, 6, they're all the same, we have to add up to 360, so 360 divided by 6 is 60. Okay, so we did all that work to find that they were 120, so we could have used that as well, but it may not always be a hexagon. We just showed the example if it was a triangle. It's going to be the same thing. They're going to add up to 360. So that practice set we will go over together. Last lesson we're looking at for this unit, we're using mixed number coefficients and negative coefficients. Again, coefficient is just that number next to our unknown. And so if we have still the same procedure, we still have to use inverse operations to try and get our unknown by itself. So if I have 3 1/3 x, so times x equals 5, first thing I would want to do is convert this to an improper fraction. So 3 times 3 plus 1. Okay. Now we're multiplying, so I need to divide. But since it's a fraction, when I'm dividing, that's the same as multiplying by the reciprocal. This gives me 30 over 30, or just 1. So it cancels out. That's what I want. That's why I do it. And I multiply this by 3 over 10. Again, if you want to draw that as 5 over 1. 5 goes into 5 and 10. We could multiply and then simplify. I always prefer to simplify before. So 2. 1 times 3 over 1 times 2. So 3 halves, 1 and 1 half. Okay, so it's still the same process. It's just we might have a little bit more work of converting and simplifying and remembering to keep change flip when we're dividing by a fraction, but it's still the same procedure. So it's nothing new, even though it may look kind of new. So if we have 2.5y, we would convert that to an improper fraction, 1 7/8, improper fraction as well. So we're going to multiply both sides by 2/5, because 5 halves divided by 5 halves is the same as 5 halves times 2/5. So we multiply both sides by 2/5, and we end up with y equals 3/4. Negative coefficients, again, just means we have a negative number right there. And it's still the same thing. If I have negative 3x equals 126, I'm going to divide by negative 3 to both sides. So if I have a negative and a fraction, over here, so I have 2/3 x equals 4/5. I'm going to divide by any number divided by itself, even a negative fraction, is still 1, but when I'm dividing a fraction by a fraction, that's the same as multiplying by the reciprocal. So, if you the negative signs of the numerator or denominator, it's still the same thing. 2 times negative 3, 5 times 1, we have 6/5, 1/5. Either way. Okay, so it doesn't change if it's a fraction or it's negative. If we're multiplying, we need to divide. If we're dividing, we need to multiply. We still use inverse operations to isolate our variable to figure out what x is equal to, or y, or whatever it is. Okay, let's say we have negative 5x equals 0.24. Okay, I'm multiplying, so I need to divide. The number over itself, even the negative number, negative 5 divided by negative 5 is 1. Okay. 0.24 divided by negative 5. Okay. Negative 0.048. All right, so we just divide. Again, if you're doing this in your calculator, just be careful that you use the correct negative sign. So if we're subtracting, we're going to use this one. If we're making a number negative, we want to use this one down here. The calculator just recognizes those differences. If I did 0.24 divided by, and then I use this one accidentally, we get an error message. So that just because we're using the wrong symbol. You know, a negative sign is a negative sign, but for our calculator, it needs a way to distinguish between those two. So that's how it does that. So we would make this negative 0.24 divided by negative 5. So use this one, then it works out. Okay. All right, well, that is it. We'll be reviewing. We'll go over practice set and everything together in class and start reviewing for this test. All right. Good job, you guys. Good start to the semester. We'll see you in class.